Okay, so we're going to use this problem here. This is just an example problem from Alex. By the way, if you guys have ever wondered how to use this stuff in the real world, here is a great example of what that is. Okay, so what we're going to do, this is solving a word problem using a quadratic equation with irrational roots. Basically, all this is saying is that when we finally solve this answer, when it says irrational roots here, it just means that the numbers that you are going to find are going to be irrational, and that's it. Okay, so a rational root just means it's an irrational answer. All right, now let's go through this real fast. This is by far one of my favorite type of problems. A ball is thrown from a height of 123 feet with an initial downward velocity of 11 feet per second. The ball's height, h, in feet after t seconds is given by the following equation. Now you look at that and you can already see, oh, I got a t squared, a t, and a constant. Oh, this is a quadratic equation right here. Well, it's also nice to know that. It's also given to you here in the fact that it says quadratic equation. So this is a quadratic equation, which means we can already, right off the bat, determine that we're either going to do a box method for solving, right? Or we're going to use the quadratic formula. One of the two. Quadratic formula. Okay, helps when you know how to spell. All right, so quadratic formula. So here's our two options for solving this problem. So before we've even started, we kind of already know what type of tools we're going to use in order to solve this. The question is, how long after the ball is thrown does it hit the ground? Okay, so let's analyze that first before we move anywhere else. How long? Okay, so how long? How long is time? Well, check this out. It's t squared and t, right? So the irrational root that I'm looking for is really time. That's your job to find. It's, okay, what's the time? Now remember, when you're using box method quadratic formula, you're going to be finding two options, and you got to determine which option is best. Now, let's look at the second part of this. Is how long meant time after the ball is thrown does it hit the ground? Okay, the ground is here. What is the height when the ball hits the ground? Just a simple logic question. Well, if this, let's say, is 123 feet, that's how tall this building is, then by logic, the ground would be 0 feet. Okay? So we're curious about how long it takes for h to equal 0. Oh, so what that means then is I take this equation right here and I say 0, because that's what h is, equals 123 minus 11t minus 16t squared. Now remember, you're using your version of this quadratic equation. This is actually great because now what I can do is I can rewrite this just a tad, okay, to be in a format that I like. I don't like it starting with 123, so I'm going to change the order. I'm going to call it negative 16t squared minus 11t plus 123 equals 0. So notice all I did was I just flipped the order here. Okay? Now, really quickly, I want you guys to notice something. 123, which is my constant, is the height of the building. Okay? The velocity is 11 feet per second squared, which is your second term right here. There's your 11 feet per second squared. And now it's negative 11 feet because you're going down to the ground, and down is considered a negative direction. This first term, that deals primarily with acceleration. Don't worry about that. But what I want you to understand here is the fact that everything you get in a problem has a specific location in the equation that you're working with. So, now that we have this equation as the way we want to see it, I've got two options. I can do the box method, or I can do the quadratic formula. Looking at this, look at these numbers. You've got a prime number here. This is potentially a prime number here. It's not, but it could be. Okay, and the reason I know it's not is you have 12 and you have 3, and I know both of those are divisible by 3. You could also use the rule of threes, where if you go 3 plus 2 plus 1, you get 6, and that makes it divisible. But my other big issue with this not wanting to do the box method is because I have this negative 16 here. This could be negative 16 times 1, this could be negative 8 times 2, this could be negative 4 times 4. There's so many options here for this that trying to do the box method is going to get very, very messy. So what we're going to do is utilize the quadratic formula in this case. Alright, so this is a quadratic formula. What I need to determine is my A term, which is negative 16, my B term, which is negative 11, and my C term, which is positive 123. So I'm going to highlight these just so that you can see it. So there's my A term, A. My B term is negative 11. There's my B term. And my C term, which I'll highlight in red, is plus 123. Okay, so you can see how that matches up now. So we're going to use the quadratic formula. Now there's a few ways to write this. We're looking for time equals negative b over 2a plus minus the square root of b squared minus 4ac all over 2a. Now, this is the discriminant, and so we're going to solve for that first, okay? So what I'm going to do is what I'm really going to look at here is calling this something different. Sorry, there we go. I don't know what happened there. Okay, so this is b squared minus 4ac. Sorry, the system glitched. Okay, the other way to look at this would be t equals negative b over 2a plus minus the square root of the discriminant all over 2a. The discriminant is b squared minus 4ac. So let's solve that first and then plug it back in. Okay? So b squared. b is negative 11, quantity squared, minus 4 times a, which is negative 16, times c, which is 123. So you're going to need a calculator for this for sure. 11, so negative 11 squared is going to be negative 120, is not negative 121, because remember this is really negative 11 times negative 11, and negative times negative make positives, and 11 times 11 is 121. This is then we have here negative times negative, so I know this is positive, positive, so this is really 4 times 16 times 23. So plus 4 times 16 times 23, 123, excuse me. And so that's 7,872, and if I add that to 121, I get 7,993. So let's plug that number right there. So now we're going to get t equals, well, okay, so negative b, so negative times negative 11 over 2 times negative 16 plus or minus the square root of 7,993 all over 2 times negative 16 plus minus. So if I take the square root, excuse me. So the square root of 7,993, that is your irrational number right there. Okay. But let's continue this forward real fast. Let me just kind of scroll this up. Sorry, didn't mean to draw that line. Scroll this up just a titch so we can see this part. And excuse me. We are going to look at, let's see, t equaling, so negative times negative, so these are positives here. So that's going to be 11, and 2 times negative 16 is negative 32, plus minus the square root of 7,993 all over negative 32. Because these have common denominators, we're just going to say that this is 11 plus minus the square root of 7,993 all over negative 32. Alright, so this is where I said you definitely are going to need a calculator for this. It's going to be too hard to do it any other way. So all we're going to do is break this into two options. We're going to have 11 plus the square root of 7,993 divided by negative 32, or, let me put or there, or 11 minus the square root of 7,993 all over negative 32. So let's go ahead and solve those now. The square root, this is going to be a big number, 7,993. All right, I'm not going to write this whole thing out, okay? But basically it's 89.404. Okay, so we're going to say this is 11 plus 89.404, go 3 decimals, divide negative 32, or 11 minus 89.404 over negative 32. So if I go 11 plus 89.404, I get 100.404 over negative 32, or 11, oops, sorry, not 11. Let me actually do the subtraction there. 11 minus 89.404 gives us negative 78.404 over negative 32. Okay, so now 100.404 divide negative 32. That's negative 3.13 seconds, or negative 78.404 divide negative 32 is a positive 2.45 seconds. Now, by logic, this makes no sense, having negative time. So we know that it will take 2.45 seconds for the ball to fall from the top of the building to the ground. Okay? And there you have it.